From looking at the source and reference footage, it should be clear how important it is to have good reference from the set. We will now take a closer look at 3 different data sets useful for lighting. LiDAR is a method for measuring distances by illuminating the target with a laser light and measuring the reflection with a sensor. Differences in the laser return times and wavelengths can be used to make digital 3D representations of the target. LiDAR scans of the set can be really useful for lighting to pinpoint light position or at least rough distances and scale of the set. If no ground is provided by the model department, it can be used to provide shadow and occlusion passes for comp to integrate your CG. We will be using our LiDAR scans later exactly for those scenarios. You won't be able to rely on the scan for the exact lighting position or layout of the set, but they will give you a good idea about it. Scans are usually done once per set, so ongoing lighting position changes wouldn't be captured. Using HDRI images in lighting is a standard workflow in the VFX industry. We will be using HDRIs exclusively to recreate and match lighting in CG. The Onset VFX crew is responsible to capture HDRIs per shot and to capture the lighting conditions. Let's take a look at how HDRIs get captured. You shoot your HDRI with a circular fisheye. What we have here is a Canon A215mm. It's set to 8mm, which will give you on a full-frame sensor a full 180 degrees coverage at any given angle. We usually put it on a nodal attachment so that when we rotate the camera, we don't get any parallax shift between the different angles. You actually want to capture it at kind of the same spot where the CG gets integrated. What you also want to do when you capture the HDRI, you want to capture as the highest dynamic range as possible. And modern cameras are pretty good, as Sony captures anything between 14 to 15 stops. What we do, we set it to bracketing. And bracketing, in this case, I've set it to 5 brackets with 3 stops apart between each bracket. This captures 180 degrees of your image, but you obviously want the full 360. So that's why what we do usually is, we angle it at one point. Capture our 5 images. So in the end, you have a full 360 coverage with some overlap. When you use that HDRI, you actually also want to kind of be able to match it to the plate footage. And obviously the plate footage is going to be shot with a different camera, if it's an Arri or Red or whatever, and your HDRI is going to be shot with, stills camera, Sony, Canon, so on and so forth. So the color science is going to be different. So that's why what we usually do when we capture HDRIs, we have our MACBET chart here, and you want it somewhere in the frame of your HDRI. So you can place it on the floor, or sometimes you attach it to the tripod. That would be your reference, and you can use the MACBET chart to kind of grade your HDRI to the footage. Reference spheres will give you the basis to create and set up your lighting. The gray sphere gives you the reference for 18% gray, and the chrome sphere can be referenced for lighting placement and intensities. The spheres also tell us how a highly reflective object and a diffuse object should respond under these lighting conditions. Since you know the shading response for both the 18% gray sphere and the chrome sphere, you can recreate the same shading on the CG spheres and use the spheres to validate your lighting setup by positioning them at the same place relative to the shot camera. Let's take a closer look at the reference spheres. The gray sphere needs to be pure 18% gray. To achieve that, the sphere we see here in the shot is painted with a special paint which matches the gray value of 18%, or N5 on the Munsell chart, as close as possible. Knowing the gray value, we are able to recreate the same sphere in CG and ultimately have a reference point to validate our lighting. As with the gray sphere, the chrome sphere has certain requirements. It needs to be as mirror polished and scratch-free as possible to get mirror-like reflections. We usually know the material it is made of, in our case 304 stainless steel. By recreating the chrome sphere in CG, we can validate our lighting position and intensities. The Macbeth chart captured is reference, so you can balance your HRIs to your shot grades. You will want to match the white point, black point, and 18% gray of the HRI to your shot to get the same lighting response from your light rig as on set.